All right, hello and welcome. Today we are once again talking about systems of equations. I'm going to be showing you a way to solve these equations or these systems using Desmos, which will come in handy for systems like the one we're looking at here, where every row has all three variables and there's not a quick substitution that we can use to like simplify everything down. So in order to do that, we're going to need to rewrite this system into what is called a matrix. And so before I can do that, I want to go through and make sure to look for any variables that are either missing or that do not have a coefficient in front. So in this first row, I notice I just have a z, and I know that every time they give me a variable without a coefficient, I know the implied value there is a 1. So I've got 1s in front of my z in the first row, and then all three variables in the second row. So to create this matrix, what I'm going to do is take the system and rewrite it using only the numbers, not the variables. So my top row becomes 3, -2, 1, and 1. I'm going to put this little line going down so that I know where the equal sign is supposed to go. I'll have -1, 1, -1, and 2. And then my bottom row will be 5, 2, 10, and 39. So when I group them in the brackets like that, I'm letting you know that this is a matrix that represents a system of equations that we were given. So the next thing that we're going to do is go over to desmos.com/matrix and input these numbers. So we notice on our screen, we've got our normal calculator buttons in the middle, got some parentheses and things over on the side, and then we've got some letters over here that don't mean anything at the moment, but will mean something shortly. So the first thing I'm going to do is click New Matrix so that I can input my numbers. I notice that when I click it by default, it only gives me 4 spaces to type. And the system I had a lot more than that. So when I go back to my numbers that I need to input, I notice that there's 3 different rows and 4 different columns. So when I go into Desmos, I'm going to click on this little plus to add rows and columns to my matrix so that my new matrix is 3 down and 4 across, just like what I needed from my system. And from here, we're basically just going to type the numbers that we need in the blanks. So my first row we said was 3, -2, 1, and 1. So I'm just going to type those in. And I'm just using the direction arrows to get to the next number, but you could also just click on them if you don't have a keyboard available. So my middle row is -1, 1, -1, and 2. And then my bottom row is 5, 2, 10, and 39. And then I'm just going to click enter to save those numbers. So notice that it says A equals and then the matrix. So anytime I reference the capital A, it should bring up the same numbers that I just typed in. So this is a good way to double check and make sure that you've entered everything correctly. So from here, I need Desmos to simplify the matrix down all the way as possible so that I can see what the values of x and y and z should be. So in order to simplify it, the command that I want is rref parentheses and then capital A. And so if everything has been done correctly, I should get a new matrix that looks like this. So I know that it has been simplified because I see the 3 ones going down the diagonal, with 3 numbers in the last column representing the values across the equal sign. So I've copied down my simplified matrix. This matrix is what we call reduced row echelon form. But really, we just need to know how to read this to interpret our results. So if we looked at the way we had the numbers positioned originally, and we mark out where all the variables were, right? Our x's were in the first column, our y's were in the second column, our z's were in the third column, and then these were our answers across from the equal sign. So this is the same thing in terms of the placement. So if I'm trying to figure out the values of x, y, and z, well, this first column is my x. So 1x equals to 5. The middle number is my y. So 1y equals to 7. And my final column is my z. So 1z equals to 0. So if I'm going to write out my solution, I'm going to say x, y, z equals 5, 7, 0. Look at one more example. So notice this time we changed the variables to A, B, and C, which isn't really that much different than what we were doing. We also will notice that we don't have all 3 variables in all 3 rows. So my first row is missing a B, and my second row appears to be missing an A. So we'll need to take note of that when we do our matrix. So I know that the variables without coefficients get a 1. I also know that the missing variables are going to count as zeros. So to keep everything organized, I'm going to go ahead and label my columns before I start filling anything in. So I need my A's first. So on my first row, my A has a 2. I'm missing the B, so that will be my 0. The C has a 1. And then the negative 10 is the number across from the equals. In the second row, I'm missing the A, so that's my 0. I have 1B, I have negative 1C, and then a 15 across from the equals. And then on my bottom row, I have 1A, negative 2B, 1C, and negative 5. So when I put my brackets in, this is my matrix. So basically, I'm going to go back to Desmos, and I'm going to change up the matrix that I had saved and see what it now simplifies to. So as we can see, when I update my numbers to match the system, my new solution looks like this. So I've copied down my simplified matrix. I'm remembering that A, B, and C were labeled in that order. So just like the first example, 1A equals 5, 1B equals negative 5, and then 1C equals negative 20. So when I write my solution, I will say A, B, C equals 5, negative 5, negative 20. That's all I have for this one. I will see you guys.